Right, question 8. We've got a nice little function, x cubed minus 10x squared plus kx. Here's just a number, just a constant. The point P on C is a maximum turning point. Given that the x coordinate of P is 2, that means that there is 2. Show that k equals 28. Now, I think this is one of the questions where it puts people off because they're not sure how to start. How do you show that k is 28? So don't worry about getting to that final point. Use some information that you've got to do something. You should read that, and when you see maximum and turning point, you should be thinking, right, well, I know at turning points, dy by dx equals 0. So kind of forget about part A, read the question and do something. And that's either going to get you nothing, which this will get you something, or it's going to get you some marks. And even better, what it might do is then get your brain into thinking in the right direction, and you'll be able to answer the question completely. So always, if you're stuck with what to do, try and read the question and do something. Read something. If you recognize it, then do that. So maximum turning point. So turning point, dy by dx equals 0. So you know what y is. Even though k is involved, you can still find dy by dx. So on the next part, just so we've got a bit more room, this is all to do with part A. So dy by dx, and that'll get us some marks. Dy by dx will be 3x squared minus 20x plus, if it's kx, if it was 5x, it would differentiate to 5. If it was 10x, it would differentiate to 10. So kx differentiates to k. So we've got 20x plus k. Now we want a turning point is when dy by dx equals 0. So let's just write that. And then try reading the question again, see if there's anything else we can do. Read what A is. So we've got the point P, which I'll put in again, has an x coordinate of 2. Show that k equals 28. Well, here's an equation with k in. So if we knew what x was, we could solve the equation to find k. And we do know what x is because the x coordinate of P is 2. So the x coordinate at this turning point is 2. So substitute 2 in there. 20 lots of 2 plus k equals 0. And you'll get an equation, really simple, to find k. And k will just pop out, really. 3 times 2 squared is 3 times 4, so that's 12. Subtract 40 plus k equals 0. So k equals 40 minus 12. So k equals 28. Done. So 3 marks. Something that, when shown, it's easy, but it's just knowing what you have to do. And like I said, you don't really know what you don't need to know straight away what you have to do. Just try some things, and that in turn breaks down the problem and then makes it a bit easier to do. So there's 3 marks. The next part I've got on a different page, quite small. It says, well, let's just put this 2 in again. The line through P parallel to the x-axis cuts the y-axis at the point N. The region R is bounded by C, the curve, the y-axis, and this line PN. So there's nothing in here that we don't already know from the diagram. We have to find the exact area of R. So areas under curves, areas to do with curves is integration. But if you integrate this curve, remember the curve is x cubed minus 10x plus, so it was k, 10x squared, plus kx, but we found out k was 28. That's the function there. Let's just double check. X cubed minus 10x squared plus kx. There, so k was 28. So this is the function here of this curve. This is the equation of the curve. If we integrate that between 0 and 2, you won't get that area R. What you'll get is this bit here. However, we can use that because then all we need to do is get the area of this rectangle, which shouldn't be too difficult. And if we subtract this black area, then we'll be given R. So what we need to do first is find out what this black area bit is, the area under the curve, by integrating. Remember, integrating the equation of the curve always gives it the area between that curve and the x-axis. So we're going to tell the examiner what we're doing. We're going to integrate between 2 and 0 because they're the limits of the area that we want. This thing here, x cubed minus 10x squared plus 28x with respect to x. And that is add 1 to the power and divide by it. So that's x to the 4 over 4, 10x cubed over 3. 28x squared over 2 is 14x squared. You don't need a plus c because we've got a definite integral. We're putting numbers in. Now we're going to substitute 2 into there. If you want to type it all in your calculator, that's fine. I'm going to do a little bit of work first. 2 to the power of 4 is 16, divided by 4 is 4. Subtract x cubed is 8, 2 cubed is 8, times 10 is 80. So we're subtracting 80 over 3. And 2 squared is 4, times 14 is 56. Plus 56. When you put 0 in, it's brilliant because you get nothing to the power of 4 divided by 4. Take away 10, that's nothing, blah, blah, blah. You just get 0. So all we're doing is working out the left-hand bracket. So on a calculator, I'm going to type in 4, subtract 80 over 3, add 56, and I get 100 over 3. I'm going to keep it as a fraction because it says find the exact area of R, so I'm not going to get any recurring decimals or anything. So that is that area here. So we now need the area of the rectangle. Now rectangle is just length times width. The problem here is we don't know the width. We don't know how high that rectangle is. This distance here can be found though, because if we find the y coordinate of P, then we found this distance. Well, we know the coordinate of P has x coordinate 2, but we don't know the y coordinate. However, we know the curve has equation x cubed minus 10x squared plus 28x. So we know a relationship between the x and the y coordinates. So if we just get 2, substitute it in there, we'll get the corresponding y coordinate, which means we'll know the height, and then it'll be dead easy from there. So for point P, we need to find y equals, we need to substitute 2 into the function of that curve. So 28 times 2. So we've got 8, take away 40, plus 56. Just do that on a calculator. 8, subtract 40, add 56. Gives me a y coordinate of 24. So this point here, we know is 24. So we know this height is 24 and this distance is 2. So this green rectangle, final bit, area of rectangle equals 24 times 2, which is 48. And then we are subtracting, so the R, which is what we want, is the rectangle, which is 48, subtract the bit that we found before, 100 over 3. So 48 subtract 100 over 3 as a fraction gives us 44 over 3, and leave it like that because, like I said, it wants exact area. And that's that question finished.